Hi guys, so today we're going to do an example for the chi-square test of independence. So I've given to you the marketing consultant for a travel agency wants to determine whether certain travel concerns are related to travel purpose. A random sample of 300 travelers is selected and the results are classified as shown in the contingency table. At alpha is equal to 0.01, can the consultant conclude that the travel concerns depend on the purpose of travel? All right, so this data in this table right now are all of your observed values. So that becomes the O in our chi-square test. What we have to calculate is the expected values. In order to do that, we need the sum of each row and the sum of each column so that we can plug those values into our expected frequency formula. All right, so this would be considered row 1. This is row 2. This is column 1, column 2, column 3, and column 4 for our concerns. So what we have to do is add together all of our sample size. That gives us 300, but I'm going to go ahead and find the sum of each row and each column. So I'm going to do my columns first. 36 plus 38 gives me a sum of 74. 108 plus 54 gives me a sum of 162. 14 and 14 gives me a sum of 28. And my third column will have a sum of 36. Then I have to go ahead and find the sum of each row. So the sum of row 1, after a quick calculation, gives me 180. The sum of row 2 gives me a sum of 120. If you want to do a quick check, because my sample size is 300, both the sum of the columns and the sum of the rows need to add up to be 300. So I can see that easily is going to give me 300. I'm going to check this 74 plus 162 plus 28 plus 36, and both rows and columns gives me 300. All right, now this is a little tedious, but for each one of these cells, I have to find an expected value. So for my first cell, my row 1 and column 1, I have to take their sums. So I'm going to take 74 for the sum of row 1 or column 1 times 180 for the sum of row 1, and I'm going to divide that by the sample size of 300. So my observed value for this cell is 36, but when I do this calculation, I get my expected value to be 44.4. So now I have to go through and I have to do that for each one of these cells. So for my second cell here, I have to kind of go through and do 162 times 180 and divide that by 300. So my second expected value is 97.2. Then I go to my third cell, which I have 28 times 180 divided by 300 gives me an expected value of 16.8. And I just continue to do this. I do 36 times 180 divided by 300 gives me 21.6. 74 times 120 divided by 300 gives me an expected value of 29.6. 162 times 120 divided by 300 gives me an expected value of 64.8, and 28 times 120 divided by 300 gives me an expected value of 11.2, And my last expected value is 36 times 120 divided by 300 gives me an expected value of 14.4. All right, so now all of the numbers that were already in the table become my observed values. All of the numbers that I've just calculated are my expected values. So now I'm going to take those and I'm going to perform the hypothesis test to see if they are independent of one another. So in my step 1, my null hypothesis, I have that the travel concern is independent of travel purpose. My alternative hypothesis is saying that no, they are dependent because these two have to be opposites. Number 2, my alpha is equal to 0.01. Number 3, when I calculate my distribution, just like the goodness of fit test, we're only going to have a right-tailed test for our rejection region. But this time, because I have 2 categories, I have to do my degrees of freedom slightly different. My degrees of freedom become my R minus 1, the number of rows, minus 1 times the number of columns minus 1. So in this problem, I have 2 rows and I have 4 columns. So I get 1 times 3, so my degrees of freedom are equal to 3. So using my table, my chi-square table, I'm using 3 degrees of freedom at 0.01. I find a critical value of 11.345. So my critical value for this test is 11.345. And step 5, we will reject if our chi-square is greater than 11.345. So step 6, we're going to have to do a calculation. If you don't have a graphing calculator at home, you can go ahead and do this in Google Sheets. But I'm going to go ahead and do this in my graphing calculator. So I'm going to edit my lists. In list 1, now this is the most important thing you can do. In list 1, I'm going to put all my observed values. But in list 2, they have to match this expected value for that cell. So you just need to make sure you do this in a proper order. So I'm going to do 36. I'm going to go down 38. It doesn't matter which way you do it as long as you are consistent when you build your list 2. So I'm going to put all 8 values in. And then in my list 2, I go in the same direction and make sure my expected values match. 97.2, 64.8. Again, you can do this in Google Sheets if you don't have a graphing calculator at home. And 14.4. I make sure both lists are matching. So list 3, I'm going to do my calculation and do my chi-square. So my chi-square is going to be my observed, so that's my list 1, minus my expected, which is my list 2. And I'm going to square that value. And then I have to take that and divide it by my expected. So I'm going to divide that by my list 2. That gives me each individual number. And as always, I need to take and calculate the sum of this list. I want the sum of list 3, and I'm going to calculate that, and the sum of list 3 gives me 8.158. So my chi-square is going to equal 8.158. As you can see, it's not larger than my critical value. For that reason, then I'm going to fill to reject. So I'm not rejecting that the travel concern is independent. So I'm going to say that there is not enough evidence at the 1% level to conclude that travel concerns are dependent on travel purpose. Purpose, I'm spelling incorrectly. There is a chance of a type 2 error, and I went a little out of order and I put that level up there, so I'm not going to mention it again. All right, so there's your test, your chi-square independence test.